but we'll start with the ones that I have. So there are questions for Romain and maybe more Jeremy, because I know that Romain couldn't stay because he had another emergency. So this was asked by where is this? Nelly Moulin. So to Romain and Jeremy, thank you for your very clear presentation. Why do we need to degrade the SAR images to compare it to ECMWF winds, or maybe the other way around? So, Jeremy, can you?
Yes, can you hear me?
To the answer? Yes, yes.
Yeah, thank you for the question. Yes, so it's just that when we compare two wind situations, we like to compare them with the same amount of information in the image. So in the data set, we have ECMWF with a 10 meter, about 10 meter kilometer resolution, and SAR images with about 1 kilometer. So we know that SAR measurements would see more details than ECMWF models. So they are different to a certain extent because of their spatial resolution. But the questions we were interested in was overall, do they measure the same wind events? And so to make sure that we don't take into account the additional information of the SAR, we just downgraded SAR to the ECMWF wind model resolution and compare them with the same amount of information.
Okay, thank you, Jeremy. I will try to kill the screen sharing of Alexi, or maybe Alexi, could you stop sharing your screen so that we see the face of those who are replying, please? Okay, thanks. Okay, then we have some questions regarding the presentation from Paul. So it deals with analogs and climate change. So there are two of them. I will maybe group them, Paul, if it's fine with you. So thank you for your presentation. It's again Nelly Moulin. Does climate change affect the chance to find analog with the recent past? And then we have another question from Stanislas Siblo. Is analog approach relevant in a climate changing context? And I will add a third one from my side if it's okay. Can we use analog to study climate change effects?
Okay. Well, thank you for these very interesting questions. I will take them in the order as Jean-François mentioned them. So the first one is about the chance to find analogs and whether this chance is affected by climate change. I would say yes, but it depends on your problem. If you're trying to look for analogs of a map of temperature, let's say, or for a map of sea level, and the catalog that you use to search for analogs is maybe from let's say 1950 to 2000, and the situation that you're looking analogs from is maybe from 2020 or okay. There of course, since there is a drift of temperature and sea level, it's well known in the theory of recurrences in dynamical system that when you have a drift, after some time, if the drift is too high, you are not able to find any analog of the new situations that you find. Say if the temperature is really high in the future, and if you look for a similar situation in the past, you're not going to be able to find one. So that's if you search for analogs of the variables that are drifting, temperatures, sea level, etc. Now there's another interesting variable to look at is pressure. And so if we look at, as was asked in the question, the recent past, there have been studies by colleagues, especially colleagues from the Laboratoire des Sciences du Climat et de l'Environnement. I'm thinking of Pascal Yu, Davide Faranda, etc. And they looked at reanalysis using either ERA interim reanalysis or Even there's a study with the 20th century reanalysis, and they have found slight changes, but slight, in the, let's say, the quality of the analogs that you find when you're searching for analogs in the recent years, let's say 2000, or when you were searching for analogs of the states that you had maybe in the 50s or the 60s. And they don't have a physical explanation for that yet. But you know what happens is that oh, and yes, sorry, I'm talking about pressure fields over the North Atlantic, so the North Atlantic Ocean and a bit of Western Europe. So it seems that the weather, the sea level pressure at this part of the Earth is more going more often in regimes of lower dimension. So, and as I've shown, if you have a lower dimension, you're able to find better analogs with the same amount of data. So it seems that in the recent past years, they were able to find more good analogs than in the past, but they don't have yet a physical explanation for that. And okay, so I guess I have answered some of the question. I don't know if there is work on the future climate projections. This part is out of my knowledge. Now the second question is using analogs relevant with climate change? And one actually my answer is related to the third question asked by Jean-François, which Jean-François asked, can you use analogs to try to see the effects of climate change? And actually you can. One way is, as in the study by Aglaé Jezekel, Pascal Yu, and colleagues from 2018, they were trying to understand the summer heat waves in Europe and trying to know, are these summer heat waves related to climate change or not? And one way to do that is to, if you have a summer heat wave, you look at the circulation, at the pressure at this time, and you try to find analogs of this circulation in the past, and you look in the past with the same circulation, did you also have a heat wave? So that's one way to separate the contribution of the circulation to an extreme event such as a heat wave. So yes, you can use in this way analogs to see the effect of climate change. But of course, you have to take care for each problem that you're looking at. You have to use a clever definition of what is your analogy. And if you think of dimension, for instance, I said that when looking at the analogs, you're able to estimate the dimension, but the dimension that you estimate is the dimension of the attractor of your data set. So if you're using a data set from 1950 to 1980, the dimension that you will find will be the dimension at this date. But if in the future the attractor has changed and the dimension of the system changes, then you're not able to estimate it in this way. And maybe one last thing is that one thing that you can do when you search for analogs is that you can use climate projections from maybe CMIP5, for instance, and so you can look for analogs in these simulations. That's one other way to leverage the problems that you can have. And I hope.
Okay, thank you very much for these very detailed questions. So I have questions again for you. Okay, and then we have a question for Alexis as well. It's from Stanislas Ciblo, and I guess you kind of replied to it when you mentioned the work on the heat waves. He asked, did you guys look at the literature know, quite ancient, about rainfall analog forecasting. A lot of work there. Some of it relevant for wind speed. Trying to read the rest of the question, but yes, some of it relevant for wind analog forecasting for sure.
Yes, I can try to be quite quick on that. So there's a lot of work indeed on using analogs for precipitation. To my knowledge, there's a forecast, but also a lot of downscaling, and that's a very famous application of analog methods for precipitation. So usually what people do is that they go from a large scale pressure field again and downscale the precipitation at a given city. And usually they use, I can actually also, I'm going to answer another, some of the other, another question somehow here, because in these studies, a lot of people who study rain with analogs of pressure, they look at pressure gradients rather than pressure itself. So analogy is measured on pressure gradients using what is called the Tewellis-Wobus score. Yes, there have been also some recent work using extreme value theory to make a better downscaling for the possible extreme events of rain. So for sure, it's relevant for wind analog forecasting. But yes, most of my efforts were dedicated to more theoretical and methodological aspects. But if we were going for a real wind analog forecasting, we would definitely use this part of the bibliography.
Okay, great. Thanks a lot, Paul, for the answers and for the great presentations. I will move on to the next question. Maybe we'll change a bit of topic. So it's from Sarah Jackson. Thanks for the great presentations. I have a question for the last presentation. In particular, the performance of the SAR Air Max compared to the best track Air Max is worse in the West Pacific compared to the Atlantic, for example. Can you say some words on this? Is this due to the difference in the best track data from different centers? Thanks. Alexis, can you hear me? Alexis? No? So I check that it's still connected. Maybe there are some technical issues, otherwise I will move on to another question. Alexis, your microphone is on.
Can you hear me?
Yes, but you're back in space, but we can't hear you. Can you hear me?
Yes, can you hear me now?
No, it's not great, but I think you can try like this.
It's not great at all.
No, I cannot hear you anymore.
Okay, so now it's good?
Let's go ahead with this. That's okay.
I'm sorry for this. Okay, so to answer this question, in fact, what you need to recall, Sarah, is that in Atlantic, the tropical cyclone center do benefit from the airplanes. So they have a lot more experience on with direct measurements of Air Max, and I think this is why they produce overall better evaluation of radius maximum than in other centers. But in general, it's also true for the MAX. The Atlantic and the East Pacific are producing the best result, or at least the result with more consistency with what we have with the satellite. And according to me, it's mainly due to the fact that they are used to get the airplane.
Okay, so maybe I don't know if you can try to do this, but you can try to add a few words in the chat or to reply directly to a question writing, because it was not so clear to me what you said. But otherwise, for sure we can transfer your contact to Sarah Jackson so that you can exchange later. Okay. Yeah. Okay, thank you. A question from Robin Marcil to Maxime and Paul, maybe to Maxime then, to change a bit. Do you think the optimal number of sensors could be related or compared to the dimension of the attractor as defined by analogs? So maybe Paul can contribute again like this.
Yeah, I can start, I think.
Go ahead.
Yes, we found a correlation between both, but we are not sure actually, because when I start to develop the methodology of the optimal number of cluster, I focused on the northern region that I presented in my presentation. We focused on the region locating west of the Brittany, and it seems that the number of clusters match the attractor number or the dimension of the attractor that Paul found. And actually, when Paul wrote this his paper, this was we all originally presented this result. This was the question of the reviewer, but finally we decided to remove this part because we need to think more about this. Maybe there is a link, but we are not sure yet. We need to think more about that. Maybe Paul can have something about this question.
Yes, I hear me. Yeah. I agree with what Maxime said. We believe that there's a link. You know, the attractor dimension that is measured with the analogs is related to the minimum number of degrees of freedom that is needed to describe the state of the system. So it should be related to an optimal number of sensors, but I guess it does depend on your definition of optimal number of sensor, which is not always easy to define, you know. But I'm pretty sure that there's one definition of optimal number of sensor which coincides with the dimension that is estimated by the analogs. But one thing that has to be taken care of, as I said, is that the dimension that we estimate is the dimension at the time of the catalog. It means somehow we assume that the attractor is the same in the database and in the present time when we try to estimate the dimension. Okay, maybe I'm going into many details.
Thank you, Paul. Again, a question for you. Very successful presentation, Paul. So it's from sorry, I'm trying to, okay, good. Trying to get back to the question. The question coming from the Sardinia Islands was analog technique used for the D-Day landing. Can you hear me, Paul?
Yes, can you hear me? Yes. I think it's I'm not very good in history, so I wasn't able to go into the details, but I read a paper from people who do history, and it seems to be debatable. So the history was that the meteorologists from Brittany were not confident about doing the invasion on the day that it was done. They believed that the weather was not good enough, and actually that's also what the German army thought. What historians say is that the German army was caught by surprise because the weather was supposed to be had many chances not to be optimal for the invasion, but some American meteorologists said that according to their forecast, it should be okay to plan the invasion on, I think it was the 13th of, I don't even know which month. Anyway, and so there are some testimony of people saying that the Americans were using analog method, but you know, it's I think it's very hard to know the real truth. But anyway, it's just to show that at the time, it's the kind of method that were used to make forecast of weather, even at large scale, because at the time, the numerical weather prediction models were not able to produce reliable forecasts. So people were using statistical methods such as analogs.
Okay, thanks a lot. Another question from Robin Murphy to Romain Husson and Jeremy Ogo. Why can't we use SAR measurements as ground truths and train for super resolution and bias correction? Any questions?
Yeah. Yeah, it's actually a really good question because we started the first approach we did was try to solve the problem with a super resolution way. But what we noticed is, I mean, I think it's completely possible. The problem was we need a clean data set that could enable such an approach. And the problem we had was, for example, with the two ECMWF model situations that were close to each other, we had really, some of them had really different collocated SAR images. So then when we throw this into the model, it couldn't really learn which one is supposed to be the ground truth. And so it was a bit lost, and then it just converged to the identity matrix. So the idea of this whole statistical approach was to define some metrics so we can try to maybe later on clean the data set. But the problem is then we have a really, really small data set for deep learning. So that's why Romain talked about having more data than we can clean and have a really proper, proper good collocated situations, and then maybe go back to deep learning with a super resolution approach.
Okay. Okay, thank you, Jeremy. Okay. So maybe I think that's enough for the questions. Thank you very much for all these very interesting questions. I suggest that we move to the last part of the meeting, which is the closure word by Bertrand Chapron. Bertrand, can you hear me? Could you give us some words about the conclusions and the perspectives for this project?
So first of all, many thanks for all the presentation. I must say that this only covers part of the work that has been developed during the CARAVELE. And we should mention that during the CARAVELE, some of the students as well as studies were performed. For the perspective, indeed, we came to many aspects. In fact, it must be said that as any project, it was maybe a little bit too ambitious from the beginning to achieve absolutely all the tasks that we were looking for. But at the same time, from the different participants and groups, we came to capabilities completely new and unforeseen from the beginning. So for the perspective, indeed, the combined capability of high resolution satellite observation, the efforts from the numerical model, and as well as in situ observation, this really we set the path to contribute to improve our capabilities, joint capabilities to assess the wind performance and the wind power performance for the different sites. And I will insist that we need to combine this different type of observation, including the numerical simulation, and we need to continue to build this combined observation and simulation synergy in a sense that it will both improve the statistical capabilities, the peak over threshold estimates, as well as to improve also the fine scale parameterization to improve the numerical simulation. So I must say that again, to insist on the fact that the different presentations were only showing part of the work that has been performed during the CARAVELE, and okay, we can maybe extend a little bit the question to open the perspective for the future. Thank you.
Thank you very much, Bertrand. Yes, again, I will repeat what you said, but there are many other results. We'll have probably a sort of one-sheet project results to be published on the same website, where we will have all the major results and the publications that we will be able to see soon on the web.